Welcome to R Tips 15. This is going to be an introduction to logistic regression in R. And this is a really cool session. We're going to determine the vehicle age, and we're going to create a model that predicts whether it's from 1999 or 2008, so about a 9-year difference. And we're going to make this awesome visualization that you see here. And how did we come up with this visualization? Well, we modeled the data, and it told us which features were important, and then we created a visualization to tell the story. And you can see here that for each of these different classes, the highway fuel mileage seems to go up from 1999 to 2008. So we made this nice box plot, ggplot. So let's get started. We're going to be detecting the vehicle age from 1999 versus 2008. And we're going to create a visualization here. And before we get started, if you haven't done so already, definitely sign up for the weekly R Tips. There's some information in the notes, so definitely check out the video notes. What you'll want to do is go to Git. Once you sign up, you'll get the access to the code. Hit the pull button, and this will download the latest version of the code. Go into your files, and if you go to 015 Logistic Regression, open up this file right here. Okay, cool. So let's get started. What we're going to be doing is first loading in some libraries. I'm going to open up the outline so you can follow along. And we're going to load on the Tidy Models library, which is going to help us with the logistic regression. We're going to load in the VIP library, and that's for variable importance. So we're going to need that, and that's going to tell us which features are important from our model. And then we're going to load in the Tidyverse library. So to get started here, what we want to do is first check out the data set that we're going to be using. So this is the MPG data set. And if you are unfamiliar, this is one of the data sets that we've been using commonly in the R Tips. It's 234 rows, and each one of these rows is a different vehicle, year, make, and model, and a different type of vehicle. So we're utilizing this in this series to be able to predict this year feature. We want to know whether it's from 1999 or 2008, and there's only two different types. So we're going to create a logistic classifier. All right, moving on. Let's do some data wrangling. We don't want to use all the data in this data set. In fact, we just want to use from here over. So what we're going to do is take this MPG data set, we're going to select displacement through class, and that's going to kind of filter out only the columns that we need using the select function. Then what we're going to do is take this transmission, we're going to encode it as either automatic or manual. We don't need the L5 and M5. So that's what this does. And then we are going to then relocate the year column, which is our target. So our year column is right here. I like that to be the first column in the data set when I'm doing some modeling. So this is my target. And then the rest of these are my predictors. And then I need to convert that year to a factor. So right now it's an integer. I need it to be a factor, which is a categorical data type. And we need that for the logistic classifier. So this is all what I call data wrangling. And if you're interested in learning data wrangling, I cover it in my 101 course. It's with the dplyr package, and in weeks 2 and 3 of that course, you learn everything you need to know about data wrangling in R. Okay, next, let's split up a train and test set. So I'm going to set a seed, and what this does is makes sure that my analysis is reproducible. And then what I'm going to do is take my data prepared and split it up proportionally into 2 different data sets. One's going to be for training our model, and then one's going to be for testing our model. So when we do that, we now have a split of 188 by 46. So 188 of these rows were randomly selected and put into our training data set. And then the other 46 rows of the 234 rows were put into a testing set. Okay, next we're going to move on to modeling. So if you're interested in modeling, I cover modeling in detail in my DS4B 101-R course in week 6. You learn XGBoost, random forest, way more powerful algorithms than what we're going to be going over in here. We're just doing a basic logistic regression. But here's how you do it. So we're going to use the Tidy Models framework. We start off with a logistic reg classifier, and then we set an engine to GLM. And what this does is it connects up to different engines. There's different types of engines that are out there that you can use. We're just going to use the basic GLM, which comes with R. You don't need to download any extra packages. And then once we have that set up, That is our model specification. We can then fit it to our training data. So our training splits is right here. It's 188 by 9. It's this data set that was randomly selected. And we're going to fit it with a formula of year as a function of dot. So year as a function of dot, and what dot means in this instance is all of these other features that are in our data set. And we're going to use those to fit. So we run that, and then we have a fitted model. And you can see it's a parsnip model object. It has some coefficients in here that has come up for our logistic regression. Cool. That easy. We came up with our first logistic regression. Now let's make some predictions. So we're going to make some predictions on our testing data set. So I'm going to open this up a little further so you can see what I've got going on. And this first, I'm using the predict function, but I'm using it in two different ways here on lines 46 and 48. You can see the type is class and then type is prob. That's the only differences between these two. I'm taking my model and I'm predicting, I'm predicting on the new data, which is my testing splits. And when I predict with a type of class, this predicts our class probabilities. So when I run this, we can check out our class, and that's just whether or not it's 2008 or 99. So these are the predictions for our testing data set. So for these 46 rows, which are in our testing data set here, we've predicted 2008 for the first 4, and we see we've got 2008 for the first 4. Then we predict 1999, and we can see that the 6th one is 2008, and that one was incorrectly predicted. So that is what the class probability is. But if you switch the type to prob, this predicts the actual numeric probabilities for each of the different classes. So this is cool. Now what it returns is pred 1999, and we can see that it's a little more complicated. So you don't just have a 2008 and 99, but you actually have a probability that's associated with that row being a certain class. And you can see what ends up happening is if that probability is over 0.5, it selects 2008, and that's what the model does up here. So a lot of times we'd rather work with these probabilities because sometimes even low probability could indicate that we want to flag it as a positive class. But that's for another day. I cover that in my 201 course, how to pick the threshold. Okay, so basically this is now the class probabilities. What I want to do is I want to bind all of the class probabilities and the class that our predictor is selecting, and I want to combine that with the testing splits so I can get kind of a full picture of my results. So when I do that using the bind calls function, I now have my predicted class, my predicted probability for each of those classes, and then I have the actual year, and then I have all of the features related to that year. So this will be a good data set when we want to kind of visualize, and we can also use it for evaluation next. So next what I want to do is I want to see how accurate this model is. So what we commonly do in classification is use what's called AUC, that stands for area under the curve. And this is how you can do it very easily. We just take our results table, which looks like this. It's got our year column, which is our actual. And then we have the predicted 1999 column here, which is a class probability. We can just run that through and we can see that we're getting an area under the curve of 0.752. And this is on the out of sample data. So this is actually much better than just randomly guessing. If we were randomly guessing, 0.50 would be what we would expect. So we're way above that. The AUC can have a maximum of 1. And a lot of times what we want to do is we want to visualize that using, instead of the AUC, but the actual curve. So we can do that very easily with this code here. And again, we're above this median, the 0.5 line, which is this dotted line. You can see our predictor is classifying with this line here. So you can see that the sensitivity tends to be greater than 1 minus the specificity, which is a good ratio, meaning that we've got some area under the curve here, and that's going to give us a positive indicator that we are predicting better than better than random guessing. So if we were at this line or below this line, that would indicate it's a bad predictor. So we've got a good model. Okay, so next what I want to do, now that I know I have a good model, I want to visualize the feature importance. So this is going to be heavy on ggplot. Visualization is covered in detail in my 101 course in week 4. So if you want to learn visualization, it's absolutely critical skill to know. definitely check out that course. I have the R track in the video notes. So the first thing we're going to do, we're going to use the VIP package, and we're going to take our model, which I'm going to extract it out of this model object. So I've got this logistic regression model. I'm going to pipe it into this VIP function. And that produces a plot that looks something like this. So this is all ggplot code. And I can see my most important features in this model are highway and the class. So I see class SUV, class pickup, class subcompact, class minivan. These classes appear a lot and they're all towards the top. So what I want to do is, this gives me an indicator that maybe it's a good idea to visualize, and that might help tell the story that the fuel economy is related to highway and the fuel economy is related to these classes. So there may be some sort of effect that I want to visualize. So next, what I'm going to do is I'm going to use ggplot here to take that data that we have already, and I'm going to plot the year versus class and highway, because I see in my variable importance plot that these are the most important features. So I have to decide what types of plots to use. I'm going to use a box plot because highway is a numeric feature and class is a categorical feature. So a box plot is a good choice for that. And when I run this series of code here, I get my visualization, and I can very easily tell the story here that older vehicles have a lower fuel economy. And I can see this by each class, where the median of the box plot tends to be higher for the 2008 models than the 1999 models. And that's kind of telling the story here that it seems like these cars have gotten much more efficient over the next 9 to 10 years, 8 to 9 years, 9 to 10 years of improvements. So that's pretty cool. And that's a good thing to, that gives me hope for the future of vehicles. So hopefully they can keep continuing to get more and more efficient. If you like this video, don't forget to sign up for the Tuesday Free R Tips newsletter. You can just click this link here and it'll send you here. Put your email address in, and every Tuesday you'll get these videos, you'll get the code, and you'll get the tutorial right in your inbox.